Hello. Continuing from last time, we want to extend the test suite, the test utilities, so that we can use a file to specify what the expected output is, rather than a string, a C string literal. So right now we have this test which is failing, and we we specify the output with a string literal, like we are required to with all our tests so far. And the thing is, the new output is going to have a lot more lines. It's going to have about a 1200 more lines, and so that's going to make the string literal very long and annoying to work with. So what I want to do is make this output, this expected output, stored in a separate file, and it'll be stored raw, like just as a raw string we expect, rather than as a C string literal. And the the test util module, let's open the header file. So it has a start test and an end test function, and the start test will indicate the start test. You indicate to it what the file is that you're currently in, like the name of the test's source file, and the name of the test, and it uses that as kind of like a way to indicate to like the person running the test, what is being run and what is failing if it fails. And then the end test method, you pass the expected string. Excuse me. And I think what we want to do is we want to add a new function here, which is end end test expecting end test file, and we don't really need to specify anything else, I think, because we're essentially going to take the file name from the expected file output name from this information here, the name of the test source file and the name of the test. And so, as an example of how this is actually used, we have test, so make map test, and so we give it the file, this preprocessor symbol, which is set to the current file, and then the name of the test here. And uh, so so yes, now right now the end test method calls verify contents function, which takes the string literal that it expects, and then it finds the actual file name. It looks at the actual file name, the actual output file name. Excuse me. This is written to this is written in the process of running the test. So if, excuse me, I need a bit of a drink of water. Okay. Excuse me. And so we have so what's going on here? In the start test function, we are setting the actual file name here, based on the name of the test file and the test case name. And then we're going to set the output standard out and standard error streams to this file, which we just opened. And these are not actual standard out and standard error streams as defined by like the C library. These are just extra symbols that we've defined, which we say you need to write to these if you actually want if you actually want your output to be testable. In a normal runtime environment, these are set to standard out and standard error. And so I think what we want to do is we want to have a new verify contents, which actually takes a file, file expected, and this file expected will be set to a string literal in the case of so it will be set to the file that we have our expected output in if we are using the file. We're going to move this stuff here to that into that file. On the other hand, if we're actually using a string literal, then we're going to set it to a stream, which is handling a string, or which is a view over a string. And in order to do that, we'll use this function that I just looked up called fmemopen, which will allow you to say, hey, use this string, use this piece of memory as the actual thing to open. And so verified contents is going to be a little bit different now because it's no longer using a string literal as its source. It's using a file or a C library stream. And so we still need this actual. Let's do it like this. So we'll copy the lines over that we need as we know that we need them. So actual stream is this car actual buffer car expected buffer, and I think I remember writing a function that would let me before that would let me kind of read over a file and automatically handle like the case where it doesn't read is all the content you expected, or it would automatically buffer the file. I wonder if I want to just pull that out. We have, let's see where it is. I think is called PB52, right? IO. See. So this function is different. It actually uses the system calls for read and writing files. It doesn't use the C library functions. So that's a bit different. So let's forget about that. And okay. So I guess maybe we do want to let's try just inlining all of this reading logic here, and not like making a module or doing anything elaborate. And after we finish writing it, we can see if we want to factor it out, because essentially we're doing the same thing twice. We're reading into a buffer and keeping track of where it is, and refilling the buffer when it gets empty. So I guess we want a size t of actual buffer end and size t actual buffer position. Yeah, I think we do want to do this. We want to, let's say IO buffer, and we have a file stream and a end size t position, and we have a buffer uint8 type buffer, and this has 512 bytes. And okay, so we do struct IO buffer expected equals expected that, and struct IO buffer actual equals 0. Okay, and so this is going to fill in zeros for the rest of the data, and this as well we'll set the first fill to 0, then fill in 0 for the rest of the data, so it initializes everything to 0. And now we want to say, so we're going to say, we're going to open each stream. So, oh, actually we can just copy this. Okay, all right. So So I don't need this anymore, or these. And now we'll go ahead and I'm going to make a while loop where we read over everything. And then we'll say, we'll make sure that the buffer is populated. Well, we might want to do like while has next or something. Now expected is written to a file here, right? Expected fn. So I think that even when we use a string literal, we want to write it to a file. And so we're just going to use fopen in the end, regardless. We don't really need fmem open in that case, because even if the test succeeds or fails, we're going to have to write the output to a file, just in case it does fail, to give the user a chance to compare stuff. And so in this case, I think what we actually so we do want to do what we've started here, but we don't need to use fmem open. Anyway, so we're going to say if not IO buffer has more expected, or not IO buffer has more actual. So I guess this will be the while loop condition. And right, so we continue this as long as we have more in the buffer. And if let's see, so we want uint 8 byte, or expected byte equals IO buffer read, and uint 8 type actual byte equals IO buffer read actual. We can actually just inline that. Let's see, delete to I. If this is not equal to IO buffer. So we can say that we have failed, and so int different equals 0, or diff is 0. So we can say diff equals 1 here, and break. And here we also want it to be, we want to also consider it a failure if there are any more bytes in either stream. If or IO buffer has more, then we also want to say diff equals 1. Now if diff, then we're going to report a failure. Okay. So expected. So I think we don't actually want expected here. We actually want a expected file name, and we'll also have an actual file name, I guess. Expected. All right. Oh, but that actual file name is a global, so we don't need that. Xf open expected fn. All right. So now if it's different, then we got to report the failure. NKS temp. And dprintf, what does that do? That prints printf. Oh, it prints it to a file descriptor. Expected file descriptor. So that's because we're using MKS temp here. That's why. But we don't really need to do that anymore. Or close xf printf. What are we using with expected FD? Exit dprintf contents. We're printing the contents to it. Okay. So we still want to do this, but even if there's no failure, we want to do it. Okay. Verify contents, expected FD. Okay, so where do we want to actually do this? I guess we want to do it in end test. End test expected. And we're going to, so this is an error that checks to make sure that we're actually running a test, and if we're not, then we report a bug. This closes the output streams. Verify contents. Still want to call verify contents, but just with a file. And then free the file name and set the file name to null. Okay, so here we want to actually set the expected, write out the expected content file expected. Or no, I guess we want to do expected fn and expected fd. Expected FD. Okay, expected FD. But we do want static void and test common. Guess because there's two ways to end the test, but they have this stuff in common here, which is to make sure that we're actually running a test currently, and that we close the streams. And then free the function here, free actual fn. Now I think we do want a util.h, which does a free here pound define, because we're going to be doing this twice. Pointer, this is due. This will free the pointer and also set pointer to null. Null. All right. Oops. Okay. Now verify contents. This is going to be the same here. Expected FD, expected, okay. Changing this to expected. And I think this is all the same now. Closing the expected file descriptor. It's passing expected fn to verify contents. And then we free the actual file name and set it to null. And test common, we still call end test common. End test common. Okay. And because we're kind of on a roll, I guess I'll also define the end test file function here. Void end test file. And this is void. And now in C++, this void is not required, but in C, if you don't specify void here, it means that it means something like you can pass any argument in there, or you're not specifying what argument to pass. And so you definitely need it for the prototype, otherwise it's ambiguous. I mean, why would you not specify what arguments you're passing, or what arguments can be passed? So that's why I added it back. I forgot. I usually write C++. So we end test file, and now we're going to write to a string. Man s printf. Now how does that work? So axs printf xas printf is my wrapper for as printf, which fails if there's an error. So as printf expected fn car expected fn. Down here we do free expected fn. And I'm guessing I don't have to initialize it. Expected fn. it is actually pointer, and we set it, we write to it. We're going to say we're going to store all the test output in a separate directory. So expected test out, and then %s, and then we're going to save. We're going to use the file and the name of the test here. Okay, but we use this also for the actual, for the expected. Wait, yeah, we're using it here too. But this is kind of different. This is a different string. I was thinking maybe we could reuse this string for the actual fn and the expected fn, but these are different. These are like the opposite thing, so we can't really reuse it. So .s, %s dot expected, or test out. I'll just leave it at that. And we do, I guess we want file and name here. Static char file and const char name, current name. Do we want to say current? Current is not really helpful. File and name. Okay. File, but we'll use it here. So test source file. Maybe we should be prefixing this with G. Say that it's global. I don't know. Name, test name. Okay. Test file. I think we want to call this source file for consistency. Call this argument source file. So start test gets better names. Source file. Okay. So then we can initialize it. Test source file equals source file, and test name equals name. And over here, when we end the test, we can clear out those values. Test source. I guess we don't want to do that because then we can't use it later. Well, we kind of do. Let's set it. And test name equals null. Down here, we need to make sure that we use it before we we set xprintf, then we do end test common here. Okay, expected test out, and then we can do verify contents. Contents and expected fn. Okay. So we have, this one's more complicated. This end test is more complicated because we're actually writing stuff to the file, writing stuff to the expected file. Now, end test common, start test, verify contents. Okay, now I think we just need to finish writing verify contents. xf get, okay. So if diff, then we can, excuse me, we want to use this again. Actual fn. So we're still using actual fn even in verify contents. So end test common, xf close out, source file test name. Yeah. I'm just thinking that some of the cleanup comes at the start of the end test function and some of it comes at the end. So end test common and then free the actual function. It's kind of confusing that we're freeing this down here, but we are kind of setting all this other stuff to nil and the original values up here. That's just kind of inconsistent, but I don't know if there's a good way to fix that. I mean, I not there's not really a great way to fix it that doesn't make it worse. And so now I think that we kind of want to have a failure function here, failure label here, instead of a variable, because that's how we did it before anyway. And I don't really have a good reason to not do it. So we'll go to failure. And here, so if has more or iBuffer has more. So actually, let's do it like this. If not has more, not has more, then we return because we're done. Otherwise, we got to print. There. Okay. Actual fn, expected fn, exit. Okay. And I don't think we need this anymore. Well, we might have to kind of use that again when we're implementing these IO buffer methods. So static int IO buffer has more. Struct IO buffer. And if IO buffer dash position is less than IO buffer dash n, then we say we do have more, return 1. Otherwise, we try and read the file. Now, xfgetS, this is, so xfgetS I think keeps on retrying if there's no if like there's no if there's nothing available, but it's also not the end of the file yet. FgetS. So I'm just wondering, does this actually do what I expect when I don't when like does it ever return 0 bytes when there's still more bytes left? Fget reads next character and returns an unsigned char cast to an int. FgetS reads in at most one less than size characters from stream and stores them into buffer. Reading stops after in a file or a new line. If a new line is read, it is stored into the buffer. Terminal byte stored after the last character in the buffer. Okay. But I don't really want fgetS. I mean, it's more like I just want like a bunch of bytes. So fgetS is not exactly what I want here, but is there something I can change it to? Like for binary, fgetWS, fgetWC, scanf, unlock standard IO, feature test macros, read. But read is a is a system call. Maybe here, C library, C read binary file. I just don't like the way it's stopping at a line. That just doesn't make sense for our use case. Fread. Oh, I guess I want fread. Read 10 bytes. Okay. So fgetS. Let's make sure we're still using git grep fgetS. We're only using it in util, test util, and check kanji database order. Excuse me. I think that we do want to use it here, so that's fine. But I think we want to also have it use read. So let's open util.h and add a read function. Read. This is return size t and gets a buffer. All right. Oops. Okay. And fd. Oh, but this uses a file descriptor as well. We want fread. Oops. Okay. Fread takes a size t and does that. Okay, let's copy that. And here. Okay. So we have fread. We're going to call it xfread. But do we need? Let me make sure I actually need that. Do I need this wrapper or not? Maybe it doesn't return error. Function reads and bytes from the stream pointer of stream, storing them at location given by pointer. And on success, they return the number of items read or written. The number equals the number of bytes transferred only when size is 1. This number equals the number of bytes transferred only when size is 1, which is not going to be true. If an error occurs when the end of file is reached, the return value is a short item count or 0. Okay. fread does not distinguish between end of file and error, and they must use these functions to determine which actually occurred. Okay, so yeah, we do need this wrapper because that is a very obnoxious API. So util.c all right. So we're going to size t, size equals read or fread pointer size and memb and stream. Now, if size feof, I guess we need to check feof. feof. How does that work? Clear error clears the end of file and error indicators for the stream pointer by stream. I guess we need to call this first. Maybe we don't because can we clear only by the function. The end of file indicator can only be cleared by the function clear error. Function FR retests the error indicator for the stream pointer by stream. Well, we're gonna die, or we're gonna terminate early if there's ever an error, so we probably don't need clear error, even though it's not clear to me whether or not fread will clear error if there's no error. But it probably, yeah, I'm not totally sure. The thing is, as soon as there's an error in the stream, we're not going to be using it anymore anyway. So we'll just use feof and error testing indicator turning non-zero. The error indicator can be reset. So it doesn't say how you get error details. You turn non-zero if it's set. Okay, so yeah. If error of stream, then let's see. How do we actually die? We print and then exit. Okay. xf printf standard error when reading file. Don't really know the name, so we can't really tell the name now. Exit. What did we use for read errors? I'll just do this. Random number. Generate 215. Okay. Error when reading file, and then we can here return size. All right. xfread. Great. Now we can actually use it. So up here we say xfread IO buffer dash buffer. Let's call it buff. And pass the size next. Size of IO buffer dash buff. And then, excuse me, number of member bytes, NMB. I'm not sure which one should be 1 and which one should be the actual size. XFB. Each size bytes long. Okay, size is the number of members. I mean the size of each member. So let's do it. Let's do it how they asked for it. And last one is the stream itself. IO buffer dash stream. Okay. So IO buffer dash end equals that. IO buffer dash end and IO buffer dash position equals 0 because we're reading from the start of the buffer. And then we can, do we want a mem set? No, let's not. I was thinking about initializing the rest to 0, rest of the bytes to 0. Maybe we should do that. IO buffer dash buff plus IO buffer dash end, set it to 0, and then it is size is going to be size of IO buffer dash buff minus IO buffer dash end. Okay. Okay. Set rest of the bytes in that buffer to 0. And the result is going to be IO buffer dash end is not equal to 0. If that is true, then we have more bytes. Okay. IO buffer has more. IO buffer read. Static uint8 type IO buffer read struct IO buffer B. Oh, I screwed up on the syntax there. Okay. Return B dash buff B dash position. Okay. Okay. Then I think that verify contents is going to work now. Contents. Okay. Let's change this. We'll say, how about, let's see, change it. Okay, size of files does not match. And this can all be done away with. Start test, end test common, end test file. Okay, let's see if that actually builds. Size t size. All right. Oh, here we go. Red size. Red size. Okay. And so test, let's see what other errors we can fix. I'll start from the bottom of the output. And then return. Control H's end of non-void function. That doesn't look to be the case. It is returning here. Name undeclared. XS. Let's fix some other errors first. Name undeclared. Okay. Test name. Test source file. And then, oh, we didn't free actual FN here. Free actual file. Okay. Oops. Make. Let's do make J1 so we only get one line of errors. 33. In function, control H is end of non-void function. And still don't understand that. Let's go to line 70. Oh, I didn't actually put a void here. Okay. And function declaration isn't a prototype. End test common. file undeclared. Did I mean nice? I didn't know I had a variable named nice. Let's go to 62. File name. Okay. Source file. Okay, let's try building again. Uint 8 type. Okay. Uint 8 type. Let's see. What file did I need to use for that? We figured it out last time. I remember we had this problem. In type def uint 8 type. bit/types.h. Uint bit/types.h sounds the most standard. Maybe standard int is more standard. Standard int. Let's try this. Okay, seem to like that. Now 23 was here. Return 1. IO buffer undeclared. Okay. B. Actually use the right name. B. Okay. B. Oops. B. Buff. Okay. And now we're here. Let's try again. 62. File. This is source file now. Okay. So here we have the actual output we wanted, and the actual output are different, which is what we already found out last time. This is because we added all the kanji to the test output. So now this is probably all right as it is. I don't know if we want to change anything. Let's actually try this out. Try this functionality out, so what I want to do is I want to actually test out this new functionality in a test case, make sure that it is working. So the negative case fails when I'm using a string literal, which is good. We want the negative case to fail. Now we also want to make sure that the positive case succeeds if we're using a golden test output file. So what tests have kind of obnoxious output? Let's do less star test star dot c. Or here. Cat star test star dot c and page it. So last rank contained is quite obnoxious. I don't really like working with that. Romaji output also obnoxious. So then free kanji keys output. What is this? Free kanji keys. Oh yeah, I remember that. Free kanji keys. Yeah, that's quite annoying. Let's change free kanji keys to use the golden output file. All right. So edit free kanji keys test. What was it called? Free kanji keys output. Where is that? That is stored in Romaji test. Maji test. All right. So I guess what we can do is we can delete this and test file with, I don't like this name, with expected file. Output with Yeah, I don't know. I can't think of a good name. And anything I type sounds like we're using like the adjective expected applies to the entire phrase output file and test content expected content in file. That is okay. I mean, it is kind of long, but it doesn't appear very much anyway. Um, and test expected content in file and edit test util.c and test. Okay. Now let's run. Okay, good. Expected. Oh, this is not the right test we wanted to fail. So we can do make. We can tell it exactly what test we want. It's called the romaji test. Make romaji. Is that what it was called? Make romaji test. Yeah. Make. Oh, we don't have to actually run make again. We can just run it. Romaji test. Okay. Output. Okay. So this means the expected output file was not found. Expected test out. All right. So we actually want to put the expected output here. Expected output here. Oh. I need to actually make the directory. Expected test out. All right, now we save it. Okay. Now run the test. So we can get the output from here. Move that to expected test out. All right. And at this point, we can probably run the test again and it will work. We don't even have to rebuild it. Oh, but we're going to do it anyway. Okay. That looks pretty cool. So let's see here. Let's see, are we really done? Oh, there was one thing I didn't like. So there are no spaces around this file name. So that is that is annoying because that means we just have some Japanese characters after it, and so if you're just skimming the output, it's not clear that the file name ends here. So I'm going to let's see, where is that defined? Let's look for that phrase. It's in util.c. Okay. All right. Okay, let's just include that. That's fine to have, I guess, in the existing commit. Now we can also look at this file and just see the test output in a much more reasonable form. Right. Yes, very good. So now we can save this. We deleted all that. Oh, let's make sure the file has the right number of lines. 1250. Okay. So let's review the changes we made in this commit so far. So we deleted that content from that file, and we augmented the test utility stuff. We started storing the test source file and the test name as global variables because we needed that after the test ended. So We created a, a very simple class-like thing here, IO buffer. Oh, do we actually close what we opened? I think we did not. Where is edit test util.c? xf open. Yeah, we open it here, but we never close it. Excuse me. So we do actually want a cleanup here, I guess. We're going to do int diff equals 0. Here we'll do diff equals 1 and go to cleanup. Excuse me. Then do diff equals 1. All right. Diff equals 1 and go to cleanup. Then if diff, then we print the error. Oh, but if we don't really need a cleanup if we're dying. So maybe this is, that's not necessary. Let's go back here. Okay. So here we can just do xf close for expected dot stream, and then do it for actual dot stream. All right. And then what did we just add? We just added those two lines. Okay. Oh, let's run everything again. Yeah, that looks good. We still have that failure in the make map test. Yeah, make map test. Okay. Still have that failure, which is what we expect. Now, to review again, yes, we augmented this. We created this IO buffer reusable module thing, which is just inlined in this other module, and we read stuff from that and compare that to the we compare the expected output and the actual output, and this time we actually store the expected and the actual output in a separate file, whereas before we did not actually write the expected output to a file unless there was a failure, but now we just write it anyway because that makes the code simpler, and it allows us to share more code between the string literal case and the golden output file case. Now, let's see. Size of files does not match. Oh, wait. Size of files does not. If IO buffer. Size of files. Oh, wait. I screwed something up here. If not has more and not has more. So if. So then we do go to failure. Yeah, if either one has more stuff in it, then we failed. Okay, now we close the files. So this is verified contents. It compares the actual contents of actual FN with the contents of the file name passed into it. Start test now does basically the same thing, but it saves the test source file and the test name to global variables for use in the end test function. And end test common now was now here because we have two end test functions, so we just kind of use that as the we use end test common to reduce the code, reduce repeated code. And when we end the test with an expected string literal, then we're going to write this to a function, a temporary file, which we've already done before. But this time we do it even when there's no failure, even when we're just preparing to compare stuff. We verify contents, and then we free the actual file name, which is what was allocated at the start of the test. And do the same thing in the end test expected content and file here. But this time it's simpler because we don't have to create the output file, right? Okay, Now, what I'm going to do is I'm going to make this commit come before the one that extends make map, because this commit does not have its test. We're not able to write a test for this that is in the way we like. So we're going to put this commit before this one, and then do some, and then we'll fix this commit so it actually updates the test. So we'll commit this, allow test cases to store expected output in file. All right. Now I'll rebase so that we have stuff in the right order. Okay. Now pending. So my pending branch is stuff that I have to clean up before I actually push it. So if we go to commit number 2 here, then we should be able to make everything and it will all pass. Oh, no, it didn't. Check kanji database order test. Lots of things failed. Okay. Go to failure. Oh, we didn't actually return 0 here. That's why. Check out pending. So here we want to return. Return. Oops. Okay, let's try that again. So we're going to add something here. We're going to use that as a fix-up for the for commit 2, and then we'll rebase. All right. Now, if we check out commit 2 again and and run the tests, they will all pass. Good. So now we can go back to pending and we can fix up the failing test case. And we'll go to pending. Let's see. It is make map test, right? Now we're going to just say end test expected content and file. Okay. And we're going to delete almost everything. Test expected content and file. Okay. Now, if we run this, we should get we'll get the command that the name of the file that we want. No file directory. Okay. So here, let's create that file, and then we can run the tests, and it'll give us the expected output here. The actual output, rather. All right. And now we can run the tests, and they should pass. No, not quite. Oh, because I didn't actually do the moving of the file. Okay, so we want to say move all right, there. Now we have the expected output right there. Now we can run it and the test will pass. Okay, very good. So now we can commit this, amend, and we'll remove this test missing thing. But I do have to finish writing that commit message. Okay, so what did we do today? New sort tasks. Okay, so we didn't do this one thing I wanted to do today about improving last rank contained. So for today, for part 10, we essentially just made the make map test testable, made the make map test maintainable by allowing you to store the expected test output in a separate file, and then we actually augmented the test for make map as we saw fit. So let me save this file. Now, there's one thing maybe we should fix before we end things off, which is that let's open the expected test output of make map test. So these codes are not in any kind of order. They're not in like a searchable order, which I think might make things hard to test. But right now they are in kind of a sane order, which is like they're easy for the user to look at and kind of reason about this sorting. So maybe it's okay. I think that eventually we're going to have to add an option to make map, which will sort these lexicographically so that so that the code is able to be searched with a binary search. So yeah, like in other words, the user types in 0, and then we should be able to look for the code 0 in here, see that it's not there because it's not incomplete, and then we wait for the user to type something else, and the user types 0M, then we do another binary search and we find the matching characters. So we need to be able to do a binary search in a timely manner, or do a lookup of this map in a timely manner. So also, we don't want any kind of oddities in the way things like non-determinism in the way this is run to cause a change in the test output. But the thing is, we're not using any hash maps, and we probably will not have to. So maybe there is not going to be any non-determinism anyway. And so, although later on when we're sorting the characters when we're sorting the codes, like the input codes 0Z, 0X, 0C, all those codes, according to how easy they are to type, there's going to be some weirdness in like the way qsort works, such that because some codes are just as easy to type as others, we may have this output, the order of the codes kind of being weird or almost random, like orders in certain subsections of it, because it's going to be a sort where some keys are considered equal to others, and where the key is how easy is something to type. And anyway, let's just leave it as it is for now, because I don't see any non-determinism in the way the test output is generated for now, so it's probably okay. And yeah, so actually we didn't have to do any other tasks, new sort tasks. But for next time, I do think I want to fix up last rank contained so that the output will be a little bit easier to read, because as you can see here, last rank contained kind of doesn't fit all on the screen at once, and it's very annoying to have to read that. So we'll probably add a flag to make that pre-printed. Anyway, that is all for now, so thank you for watching.